Hello everyone. So let's discuss the solution for the given problem. The problem states three concentric metal shells A, B and C of respective radii A, B, C in the increasing order have surface charge densities positive sigma, negative sigma and positive sigma respectively. The potential of shell B is. The solution to this problem is very simple. Just a single formula, that is the formula for potential of a shell charge of a shell at a given on the surface, right? And the formula is k into charge into 4 pi r square, that is the distance from the center upon the radius b of the shell, right? So uh, to calculate the potential of shell b, that is vb, we calculate for shell a. Okay, so k into sigma, that is positive sigma, into 4 pi a square upon b minus potential of shell B upon B, that is potential of charge at B is negative sigma, hence the negative sign here. Now the charge at C is positive, so as similar to first term, K into sigma into 4 pi C square upon C, as C is a bigger radii. Okay, so here we go. Simplifying this equation, VB is equal to taking sigma by epsilon naught common. Epsilon naught is K here represent 1 by epsilon naught, which is written here. Okay, so sigma by epsilon naught, in bracket there is a square by b from this term minus b from this term, as 1b cancel out, plus c as 1c cancel out. So a square minus b, a square by b minus b plus c. Okay, so VB is equal to sigma by epsilon naught a square, taking b common in the first two terms, a square minus b square upon b plus c. That is similar to option D given in the question. So option D is the correct answer.